Our next example in computing reactance, we are given the resistor is 6.5 kiloohms and the magnitude of the impedance is 9.8 kiloohms, and we would like to find the capacitive reactance and the phase angle. Okay, so I'll go ahead and draw the phasor diagram again. Okay, so there's our resistor, 6.5, and then we have an impedance. This is R, and then Z is 9.8, and what we want to know is the capacitive reactance, XC, and the phase angle. Okay, now we know that R squared plus XC squared is equal to Z squared. So if we need to find XC, then we're going to need to subtract R squared from Z squared and then take the square root. We get XC equals square root Z squared minus R squared. Okay, so let's go ahead and do that. And it turns out that we get 7.33 kiloohms. Now we know XC, and we know that the phase angle theta is the inverse tangent of XC over R. And so this is the inverse tangent of 7.33 divided by 6.5 with a negative sign, but I'm not going to be concerned about that negative sign. And the answer works out to be 48.5 degrees approximately. Okay, now let's analyze a RC circuit in its entirety. Okay, so we're given R equals 28 ohms and C is equal to 0.47 microfarads, and F, frequency of excitation, 7,400 hertz, and the magnitude of the excitation E is 5 volts. We want to find XC, Z, VC, VR, and I. And you should try to do the problem in the order that it's given. I don't think you can work the problem successfully if, say, you try to find I first. That's not going to work out. So what we should do first is to find XC. So we know XC is 1 over 2 pi times F times C. So in this case we have 1 over 2 pi times 7,400 times 0.47 micro, which we know is 10 to the negative 6. So I'm going to calculate that denominator and then take the reciprocal. 2 times pi times 7,400 times 0.47 times 10 to the negative 6. And we get 0.02. Now we do the reciprocal, and the answer turns out to be about 46 ohms, 45.7. .7 ohms. Okay, now that we know XC, we can go ahead and find the impedance Z. Z is, or magnitude of Z, I should say, is square root sum of the squares of the resistance and the reactance. So we have 28 squared plus 45.7 squared. I already have the 45.7 here, so I'm just going to square that and then add my resistance, 28 squared, and we get 2878. Take the square root of that, and the answer is 53.6 ohms. Okay. Now, while we're at it, we can also go ahead and find the phase angle, and that will be the inverse tangent of XC over R, and that gives us phase angle 58.6 degrees. And once we know the phase angle, then it's easy to calculate the values of the voltages across the components. Okay, because we know that VC is equal to E times the sine of theta, and VR is equal to E times the cosine of theta. Okay, that comes from the phasor diagram. Okay, so this one is 5 times the sine of 58.6 degrees, and this is 5 times the cosine of 58.6 degrees, and so those values turn out to be 4.3 volts and 2.6 volts respectively. Finally, if we know the voltage across the resistor, then it's easy to calculate the current. Okay, from Ohm's law, we have I is equal to VR over R. So that's 2.6 divided by 28. And the answer is 93 milliamps.